Good morning, guys. Today we're going to be starting section 2, which is simplifying radicals, and we're going to be looking at the product rule today. So when simplifying radicals, you want to look for perfect squares that make the radicand. That's the number inside of the radical. So you can simplify each of those pieces to pull them out of the radical. A radical is completely simplified when there's no perfect square that can divide the radicand. Okay, so what that means is you're going to look at the number inside of the radical, and if there's a perfect square that divides it, you're going to want to divide it by that and then simplify the resulting radicals. So it's going to be very, very helpful for you to know your perfect squares. So your perfect squares, 1 squared is 1. So 1 is the first perfect square. 2 squared is 4. 4 is the next perfect square. 3 squared is 9. 9 is the next perfect square. 4 squared is 16. 16 is the next perfect square. Then it'd be 25, then 36, then 49, 64, 81, 100. It's probably best to know up to 15, honestly. 121 would be next. 144, 169, 14 squared is 196, and then 15 squared is 225. So if you can remember all of those perfect squares, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225, this section is going to go very quick and very easy for you. So I'd highly recommend doing that. Okay, so here's how you do it. It's very simple. You look at the radicand, the number under the radical, 54, and you ask yourself, which of these numbers divides 54? And 9 does. 9 times 6 is 54. So we can say that the square root of 54 is the same as 9 times 6, so the square root of 54 is the same as the square root of 9 times the square root of 6. And I put that perfect square first because it simplifies. What's the square root of 9? The square root of 9 is 3. So the square root of 54 simplified is 3 square roots of 6. There's no perfect square that will divide 6, so that's as simplified as it can get. So mathematicians like to, it's kind of like reducing fractions. You got to reduce your radicals by finding perfect squares that divide it. Number 2, this one's nice and easy. 4 divides 12. So 4 times 3 is 12. So the square root of 12 is the same as 4 times 3. The square root of 4 times the square root of 3. The square root of 4 is 2. And then you've got that square root of 3 that tags along. There's no perfect square that will divide 3. 200, again, very easy. There are multiple choices. You could choose 4, 25, but you always want to go with the biggest, and the biggest would be 100. 100 is the biggest that would divide 200. So that would be 100 times 2 is 200. The square root of 100 is 10, so it would be 10 square roots of 2. Number 4, the square root of 35. I'm thinking about what makes 35. There's either 7 times 5 or 1 times 35. And 1 wouldn't change it because the square root of 1 is still 1. So you don't really ever pick this one. This isn't one you pick. There's no perfect square that's going to divide 35. 4 doesn't divide it, 9 doesn't divide it, 16 doesn't divide it, and then 25 is too big. So it cannot be simplified further, or you can say it's already simplified. We'll move on, a few more examples here. Square root of 24 is next. Again, 4 divides it. I don't think anything bigger does. So you'd say 24 is the same as 4 times 6. The square root of 4 is 2. So you have 2 times the square root of 6. 2 square roots of 6. No perfect square divides 6. That's as far as it will go. Looking at 60. 4 divides it for sure. Does 9? No. Does 16? No. Does 25? No. And 36 is too big. So 4 is the biggest one that will divide it. It is 4 times 15 is 60. The square root of 4 is 2. And we know that the square root of 15 doesn't simplify because we checked anything bigger. The square root of 42. Does 4 does not divide 42. That one's tricky. It's not 4. Does 9 divide 42? No. Does 16? No. Does 25? No. Does 36? No. It's too big. This one's already simplified. There's nothing, no perfect square that divides it. Number 8, that one's pretty easy. Anytime it's something 100, it's going to be 100 times 3 in this case. Square root of 100 is 10, so 10 square root of 3. All right, on numbers 9 and 10, we've just got a number out front. It doesn't make it any harder, just one small little step. So just look at the radical again. Square root of 8, is 4 times 2. And then just bring that 3 out front. What's the square root of 4? 2. So we have 3 times 2, and then the square root of 2, right? And what's 3 times 2? 6. So 6 square roots of 2. Let's try that one on 10 again. So what divides 40? 4. 4 times 10. Bring that 5 down. Square root of 4 is 2. So we've got times 5. 5 times 2, 10. Square root of 10. 11. There's a negative out front. Doesn't change anything. Look at the 27. 9 times 3 is 27. Square root of 9 is 3. So I've got negative 5 times 3 and also a square root of 3. Negative 5 times 3 is negative 15. Number 12, what divides 75? That would be 25 times 3. What's the square root of 25? 5. So we've got negative 3 times 5 and then also a square root of 3. Negative 3 times 5 is negative 15. And you got the square root of 3 that tags along. Doesn't make it any tougher, does it? Okay, on the back, we're looking at the quotient rule. It's just saying, so it says if you have a square root over a radical fraction, you can separate it into 2 separate radicals. So that's what we're going to be doing here. We're going to take that radical and we're going to separate it into the square root of 25 on top and the square root of 36 on bottom. That's much easier to look at. What's the square root of 25? 5. What's the square root of 36? 6. So all of that equals 5 sixths. Number 2, again, you're going to separate it to the square root of 3 on top, the square root of 64 on bottom. On top, does the square root of 3 simplify? No, there's no perfect square that divides 3, so it's going to stay the square root of 3. On bottom, we know what the square root of 64 is. It's 8. So it simplifies to the square root of 3 over 8. On number 3 here, you're going to say that's the square root of 40 on top, the square root of 81 on bottom. So let's look at that top. Is there a perfect square that divides 40? And you say yes. What divides 40? 4 times 10 is 40. What's the square root of 4? 2. So 2 square root of 10. On bottom, what's the square root of 81? It's 9. That doesn't simplify any. And that's as far as you can go. Now here's what you need to keep an eye out for. If 2 and 9 are both divisible, so if this was like 2 over 10, you can divide both of those by 2. You can't ever reduce the radical part, but you can do the whole number parts, okay? Let's look at 4, 5, and 6. If you want to pause the video and try them, that would be fine. We can compare answers. They're a lot like 1, 2, and 3 up above. Otherwise, here we go. We'll see how you did. Square root of 5 on top, square root of 49 on bottom. That's just the square root of 5 over 7. Number 5, you've got the square root of 9 on top, square root of 100 on bottom. They're both perfect squares, so that would be simplified to 3/10. On 6, you've got the square root of 18 on top, the square root of 25 on bottom. I look at that square radical there, and it's divisible by 9, so it's 9 times 2. And that's 5 on bottom. Square root of 9 is 3. 3 square roots of 2 all over 5. And there you go. That's it for the day. Again, just try and remember those perfect squares. You can do these things very, very quickly when you know your perfect squares. Let me know if you have any questions. Good luck on my math lab. We'll talk to you soon.